Welcome to today's tutorial. Today, we're diving into an exciting intersection of technology and urban planning. How artificial intelligence is transforming traffic management systems for smart cities. We'll explore the techniques and code implementations that allow us to analyze traffic patterns, optimize signal timings, and ultimately reduce congestion. Before we jump in, let's talk about the problem we are solving. Traffic congestion is not just an inconvenience. It heavily impacts our environment, economy, and quality of life. Traditional traffic management systems often rely on historical data and fixed signal timings, which don't keep up with real-time traffic conditions. Here's where AI comes into play. By leveraging machine learning algorithms, we can analyze real-time data to make dynamic adjustments to traffic signals and improve overall traffic flow. In this tutorial, we'll create a simplified AI traffic management system using Java, integrating machine learning for traffic prediction and control. We will use a handful of libraries, Weka for machine learning, and an example database of traffic patterns. Make sure to set up your Java environment and include Weka in your project dependencies. Let's start by setting up the project structure. Create a new Maven or Gradle project and structure the source code as follows. 1. Create a directory called src/main/java. 2. Inside it, create a package named Traffic Management. 3. We will have three main classes: Traffic Data Collector, Traffic Predictor, and Traffic Signal Controller. Each class will serve a distinct purpose. First, let's structure our main class, Traffic Data Collector. This class will handle the collection of traffic data, potentially from various sensors or databases. Let's implement a basic version of this class that simulates collecting data from traffic sensors. Next, we will create the Traffic Predictor class. This class will use machine learning to analyze the collected data and predict traffic patterns. For simplicity, we'll use a regression model from Weka. Here's how we can structure our Traffic Predictor. Finally, let's implement the Traffic Signal Controller class. This will manage the traffic signals based on predictions provided by our Traffic Predictor. We will implement a simple logic to turn the signals green for intersections that require flow. Now, let's connect everything in our main application. We will simulate the traffic data collection, training our model, and controlling traffic signals based on predictions. As you can see, we have a basic framework for an AI-enabled traffic management system. We simulate data collection, train a model based on that data, and control the traffic signals accordingly. Remember, this is a simplified version. Real-world applications would involve robust data collection, advanced models, integration with IoT devices, and significantly more complexity. To enhance this system, we can implement real-time data streaming using tools like Apache Kafka, which can help manage data flow from various traffic sensors. Add more sophisticated predictive models using deep learning frameworks like TensorFlow or Keras. As a next step, I recommend exploring how to integrate actual traffic data APIs, such as those from Google Maps or Mapbox, which can provide real-time information on traffic conditions. Utilizing those, you can augment your predictions with external data sources. Thanks for joining me on this journey through smart traffic management with AI. If you found this tutorial helpful, consider subscribing for more content on Java programming and technology tutorials. Let's work together to develop solutions that enhance our cities and make a difference.